Hello everybody and welcome. In today's video we're going to be going over the chain rule and going over these three examples shown on the screen. So without further ado, let's shake and bake. Example number one. So we have y is equal to this function here, and the basic formula of the chain rule goes as follows. So dy over dx, which is just the derivative, is equal to the derivative with respect to u times du with respect to x. All right. And another way to look at it is this right here is the outside function, and this right here is the inside function. Okay. So the way we do this is we're going to set something equal to u to make our derivatives easier. So I'm going to go ahead and set the inside portion here equal to u. That's going to be our u value. All right. So if we were to look at our formula, what we'll have is the derivative is equal to dy over du, which is the derivative of our new function, which is u cubed, right? So this comes from up here. When you set u equal to the inside, then you have u cubed. This whole thing is going to be multiplied by du over dx. So the derivative of our u, what we let u equal to, but with respect to x. So that's x squared plus 1. All right. So this portion here is the outside function, and then the second portion is the inside function. All right. So let's go ahead and continue this. So dy over dx is equal to the derivative of u to the third power is 3u squared, and we're going to multiply that by the derivative of x squared plus 1, which is 2x. All right. Now, the last thing we want to do is we want to replace this u with what u is, equal to. So, what we know is that dy over dx is equal to 3 times 2x is 6x. Our u value is x squared plus 1, and now that is squared. So this right here is the derivative to that function. Therefore, this example is complete. Example number 2. So we have this function here. What I'm going to do is I'm going to set the inside here equal to u. And now we're going to do a little bit of manipulation to the problem. So we have now y is equal to -7 divided by u squared. And I'm going to bring this u up to the top. So we got y is equal to -7u to the negative second power. Okay, so now we can go ahead and take our derivative here. So our derivative dy over dx is equal to dy over du, which is basically just the derivative of our new y value, or a new y equation, which is -7u to the negative second power, and that's going to be multiplied by the derivative with respect to x of our new u value, which we set to 2x minus 3. All right, so now we can go ahead and continue. Dy over dx is equal to the derivative of this right here is -2 times -7 is 14 u to the negative third power, and we're going to multiply that by the derivative of our u value with respect to x, which is just going to be 2. All right, so let's simplify. So dy over dx is equal to 14 times 2 is 28 u to the negative third power. Now I want to make that exponent positive. So dy over dx is equal to 28 over u cubed. And now the last thing we have to do is just plug in our u value. So now we have dy over dx is equal to 28 divided by our u value, which is 2x minus 3, and that is raised to the third power. So this right here is the derivative, therefore this example is complete. Example number 3. So we have y is equal to this function here. I'm going to rewrite this a little bit to make it visually easier to see. So that is the same thing as sine of 4x cubed. A lot of times we'll just write the exponent right over here just because it's easier to write. So this is the same exact thing. What we're going to do first is set the inside equal to u. So u is equal to sine of 4x. And then now when we're looking at our new u, the one that we just set it to, we can see that that's also a composite function because of this 4x here. So now what I'm also going to do is I'm going to let's call it v equal to 4x. Okay, so this is going to be a double chain rule. We're going to have to use it more than once. So let's go ahead and start here and try to explain it. So our derivative is going to be equal to the derivative of the outside function. So dy over du of u cubed, right? Because we let u equal to sine of 4x, and we just plug that into the equation up there. The next derivative we're going to have, so we're going to multiply this by du, which is du divided by dv. dv. Okay? And that dv is because 4x is equal to v, like we said. So it's going to be times sine of v. And then our third one is dv with respect to x of 4x. Okay? So one way to kind of look at what you're going to be taking derivatives of is you look at the bottom letter here, which should be the letter that is going to be inside. So you see that there's a u there and a u there, a v here and a v here, x here and an x here. So now we can go ahead and take the derivatives of all of these, and that will be our answer. So dy over dx is equal to the derivative of u cubed is 3u squared times the derivative of sine of v with respect to v is just cosine of v times the derivative of 4x with respect to x is just 4. Okay, so now we can go ahead and plug in all of our variables, and what we get is dy over dx is equal to 3 times our u value, which is sine of 4x squared, times cosine of v. Our v value is 4x times 4. Okay, so let's go on to the next page and simplify this a little bit more. So simplifying here, we'll have dy over dx is equal to This 3 can be multiplied with that 4, so we have 12 times sine of 4x squared times cosine of 4x, which is an acceptable final answer. However, if you want to use the same notation that the problem gave us, we would have 12 sine squared. You just put that exponent right there. 4x cosine 4x. So that there is our derivative. Therefore, this example is complete.